Welcome to Rubber Duck Engineering. Tonight, we're going to do some Advent of Code, which I've never done, including a problem about lava tubes. It'll be fun. Hey, Dr. Barth.
Hey, Eric. How's it going?
You know, one of the best weeks I've had in a long time. It's been kind of amazing. The stars have aligned. I'm dreading a little bit the reversion to the mean that is inevitably going to happen, as things go. But it's been a really good week. Really good week, really good day.
You should just enjoy the week. Don't worry about the reversion to the mean.
No, it's been great. Work's been going well. We just launched Flutter for Windows today, which went super well. We hired a bunch of people recently who are doing super amazing. We had a bunch more people joining next week, and things are going really well at work. I had various extended family who had were sick recently, and they're no longer sick, so that's all good, and so it's all good.
It's really nice when those sort of things come together. It's really good to have high highs and appreciate them and enjoy them. And
yeah,
we as things have not been going so swimmingly this week. My youngest child vomited all over the living room rug last night. So we took the rug outside, and it's from Costco. It's one of these rugs you can it's an indoor outdoor rug, so you can hose it down. Yeah. So we hosed it down, and then it got really wet and really heavy. So we tried to prop it up in some way where it has some chance of drying, but I don't know how it's going to turn out.
Yeah, in California winters that are not that sunny during the day.
No, but at least it's not raining, so it's not getting more wet as time goes on.
We were attempting to diagnose before the show, and I apologize, everyone. My camera flickering has gotten worse, and I really need to get it fixed.
I think it's one of those effects, you're from the future, and your signal is breaking up a little bit because it can't quite come back in time, right?
There you go. That must be it. I'm from the future. So tonight I got the suggestion actually from Tim, who I work with. He was like, "You should do Advent of Code," and I'd never done Advent of Code. I'd heard about it, and we went and looked at the site, which I can pull up here, and it's cool.
It looks really neat. I hadn't really I knew it was a thing, but I hadn't ever dug in and looked at their problems.
So this is the this year's one. And then they have these problems that are just really nicely written, and they look like they're fun to solve. And then you can log in and see, and sort of compete of sorts. I realized I should have logged in before the show. I'll do that here in a second. And we were going to look at, we just sort of picked one out of a hat. And this one looked like it was fun. Oh, it's Smoke Basin. I titled the episode Lava Tubes because that sounded exciting. So we're going to do this one tonight.
Should we read the problem statement?
Yep. So this actually really feels like a game programming kind of problem to me. So these caves seem to be lava tubes, part or even still volcanically active, small hydrothermal vents. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a heat map of the floor of the nearby caves for your puzzle input. The smoke flows from the lowest point in the area it's in. For example, consider the following height map. So height maps are totally a normal thing in games, in 3D environments. So that's what that reminded me of. Each number corresponds to the height of a particular location where 9 is the highest and 0 is the lowest. Normally, I would think of it as being 0 to 1, but that works just fine too.
I think they want to present it as a string.
Sure, because you're not going to present floats in a string. Our first goal is to find the low point in locations that are lower than any of the adjacent locations. Most locations have 4 adjacent locations, up, down, left, right. Locations on the edge have only 3 or 2. Okay? Diagonal locations do not count as adjacent, sure. In the above example, there are 4 low points, all highlighted. 2 are in the first row, 1 and 0, and 1 is in the third row, and 1 is in the bottom row. All of the locations of the height map have some lower adjacent location. So, I'm sorry. All of the locations have some lower adjacent, so are not low points. Great, okay. Risk level of a low point is 1 plus its height. In the example, the risk levels of the low points are 2, 1, 6, and 6. The sum of the risk levels of the low point of the height map is therefore 15. Okay. Find all the low points in the height map. What is the sum of the risk levels at the low points of your height map?
Okay. Sounds like sort of like normal kind of setup for a programming puzzle where they give you some numerical input that you got to like crunch and create some output that's easy to check whether you did the right thing.
What's interesting here is that they're only checking for the right answer. Again, I don't know how much of there's like a competition feel to this, or how much of it's just like, hey, it'd be fun to solve a different programming problem every week. Tim was saying that he was doing them all in Dart as like a, just a play around with Dart, which sounded fun. So we're all set up to go. We got a replit and it's in Python. I have to log into this in order for us to get our seed, but we don't actually need to do that now.
Should we just start by copy and pasting the example from the instructions?
Yeah, exactly. We can just make this work and then we can deal with checking it later. You're going to make me write Python, aren't you?
It's fun to work with different languages, and why not Python?
What? I don't even remember. How do you declare Python?
Nothing. There's like no syntax in Python.
Okay.
Yeah.
Oh, but multi-lines or triples?
You could do like a raw string or something. Oh yeah, triple quotes.
I said to you, you're gonna make me do Python in the pre-show, and he's like, Eric, you wrote 40,000 lines of professional Python, and it's true.
To be fair,
but
that project started with a single Python file that then grew and grew and grew until it was huge.
Yes.
Caverns. Oh, this is the lava tube.
Yeah, it's the map. Really, it's the height map, right?
Submarine map.
Okay.
I just like the evocative flavor. Let's put a new line at the end just for the sake of our sanity's sake.
Okay. And so so what are we trying to do? We're trying to find.
My first instinct is to split this into like a multi-dimensional Python array so that we can work with it more easily.
Yeah, sure, and Python will do that super easy. In fact, I think it already sort of.
Split, right?
I think you can just split by new line. You're done. Because arrays and strings are the same in Python, aren't they?
So this is like
it's all duck typing. Map is a keyword.
Right?
That's a function name.
Oh, okay.
In Python, map is a free.
First.
Sure.
Let's see what this got. Install Poetry. Yeah, that looks legit.
Yep. Looks like we don't need this extra one, but it doesn't matter.
Okay.
Okay, so there's our parsed thing. So we have to like figure out whether something is a low point. Yeah, the risk level sort of, yeah. But so first of all, we have to sort of identify what are the low points.
So I feel like we just want to walk through this multi-dimensional array.
Well, this also feels like a normal problem in game programming, where you have like a flow map, like for navigation. I think that's what we're kind of just trying to think if there's like nice ways for us to.
You're trying to think like a fancy algorithm? Is that what you're thinking about?
Yeah, it doesn't even be fancy per se. Go ahead.
I was thinking the dumb algorithm would just be to walk through every index and then look up, down, left, right, and see if it's lower than all of those.
Sure. Yeah, that seems like a totally reasonable dumb algorithm.
Do you want to start there?
Yeah.
Or do you want to think some more about it?
I'm just thinking. But sure, you can just do for line in parsed.
No, you're punctuating too much. Yeah.
Halfway.
My guess is we're going to want the index.
What is that?
I think you're going to want the index because I think you're going to want to. I think you're going to want the index. I think you're going to want to like index around in the parsed.
So for index in main, because Python does it this way, right? It's, parsed 0.length. Parsed dot.
I think it's len.
Oh, you're right. Len time. Python, everything is a freaking free function.
Python is. Well, they have all these like iterables, and this is like the row,
not
right?
quite right. You need to do parse len times len parsed 0.
Oh, okay. So you just want to. I was gonna have an XY, like a 2 nested for loops, like.
Oh, you can do that. Okay. That's fine. All right, let's make it so.
Maybe we should like.
This should never be different, right? This should just be like parse 0. This is like width and height.
Like our width.
Yeah, exactly.
Yeah, let's pull that out. Okay.
Yeah, that makes a lot more sense. And even though Python will only call that once.
Well, we're going to need it to do like the bounds check and stuff. So it's going to be a useful quantity for us.
No, I totally agree. This is definitely the right way to go.
Okay. So my favorite thing about Python, by the way, while we're using Python, is you just start by like writing the code. Like you don't have to write any functions. Like it passes my like hello world is hello world test. It's not quite like hello world is not quite hello world, but it's really close to hello world.
Okay,
should we just print this out to make sure we got something sane here? Like print X. That looks sensible.
Optimization would be on 3rd year, so I think you can bird force. Yeah, and I don't think that's mean like 3rd year of uni. I mean like the 3rd year of something existing. You can worry about optimizing it. There's another version of that which is like premature optimization is the root of all evil, and it is true.
So I saw recently on Twitter somebody posted the scan from Knuth's book where that quote comes from. And I'd never seen it in its original context.
Yeah.
But basically, he was saying that because programmers have such bad intuition for what parts of their program are the bottleneck, that you basically have to build the whole thing, then analyze it, and that will then point you to the part that you actually should optimize. But I think he was like I think the context in which he was speaking was people who were doing mostly assembly programming. And they were really clever, really tightly packed assembly for things that didn't matter and then were totally incomprehensible. But I mean, it still applies in our modern world too.
No, I mean that meta point of that, or just that point of that programmers are bad. I mean, humans are bad at understanding what's going to matter, predicting, and computers just change so much. Like they're just so much faster than they were when I was a kid. All right, so you really want like a lookup function here. You want a lookup function that like either returns like yeah, so you want like fun, fn, def. It was in there somewhere. Look up. Oh God, Python. Python is so duck typing languages have so many problems.
I mean, they're good for like the scale of program.
Well, because the problem with it, one of the problems with the duck typing language is if you want it to continue working, you have to have a unit test that covers every single line of code.
So in this 40,000 line Python program that Eric and I actually worked together on, we literally wrote unit tests that hit every single line. And so we got into this like, it was basically like a engineering workflow automation tool.
Wait, was
like we ended up having to like mock out things like creating processes and like reading the file system. And so we built a whole in-memory file system and a whole like fake in-memory process thing. And then you basically run the workflow tool and you give it this like fake file system to work with. And it would tell you, here are all the commands that I ran on your fake file system. And then through that, we were able to literally execute every line of code. And any line of code that we didn't execute in the unit test immediately broke. And then we found that the unit test thing broke. So we had to write unit tests for the unit test thing. It's like out of control. And like, it worked in the end, but it was really required a massive amount of testing.
Okay.
So if it's out of range, actually, you can just return 10.
Exactly. That's where I was going.
Oh, awesome.
Right. I mean, really, for sanity's sake, we should make it a valid, right? Or like max or something like that.
Yeah. Mm-hmm. Yeah, like document this random constant.
You never want to write a single constant. You want to instead write a, just because if you ever use a constant, like use a literal as a constant, you will kick yourself when you ever try to change that constant, or when you try to understand why is there this magic number in the middle of my program.
Like works if you use the same constant in 2 places.
Okay.
If you use the same constant in 2 places, and then they get out of sync, or maybe they're actually different things, and so they should get out of sync. Like it's just.
Yep. And then you
don't
change
name your
later
constants.
Okay. And I really should give it a better name than max. That's terrible. I'm squatting on the namespace here, but it's fine. We're 40 lines.
Well, max is really 9, right? So you want to return back max plus 1.
Well, but that itself should be its own constant instead of. If you want, right?
This is where like the null-aware operators in Dart are really nice. Like you could. I guess Python has none, but I'm not sure if it's how easy to work with it. Yeah, I'm not typing the brackets.
Python, I do like. There are things that I do like about Python. I miss about Python. Like I really enjoyed the like list-based processing. The like MapReduce is like super easy in Python. Like literally, they have built-in functions map and reduce, and generator patterns. There are things that are nice about Python. Okay. But having to unit test every single line of code is not one of them.
To be fair, I wrote Python just 2 days ago in my job. So we're doing a memory analysis of a system. It's like how little memory can we run our system in? And the memory tool just dumped out this giant JSON blob of here's all memory in the system and like who owns it and what they're using it for. And I just like wrote a bunch of Python to like data process that and spit out some visualization. And it was just perfect for that. Like but I'm not ever going to maintain that. Like I just want to run it to see what the answer was.
One of the first, well, I don't know if it was first, but an early language that I learned right before getting my first job was Perl. And I've forgotten it all. And I regret any time I ever spent writing Perl because it's just sort of a worse version of Python. I'm sure I'm starting a religious flame war here. Or maybe Perl is dead enough now that people don't get religious about it. But Perl's problem in life is you just, as they say, it's a write-only language. You can only ever write it. You can never actually understand what you wrote that one day. Python, you can at least have a chance of reading. All right, what is this here for? This is
basically give it a coordinate. Give me the least thing that's nearby.
Why?
Because then I'm going to call it here. I'm going to say
to compare with.
Yeah, if level is less than least nearby, why? Then it's a low point, right?
Okay.
So then we're supposed to compute the risk level. It's like risk level gets incremented by the level plus 1.
You are comparing it to itself, which is fine. What happens? What do we do if two things are? Do they both count as low points if there are two identical values next to each other, or is that not allowed?
Well, let's read the rules. What do the rules say? First, yeah, we should definitely have a test case for that. So let's test when two adjacent.
A file says, to be fair, you can specify type now and run MyPy to analyze. I don't know what.
Well, yeah, all the untyped languages have grown optional typing systems. Yeah, because like types are now in fashion. Like the pendulum has swung to types in the world, and so all the untyped languages are growing type systems.
That's amazing. Well, but they're only sort of type systems. Like TypeScript is only sort of a type system.
Yeah, but like they help you with this problem of like, is it a string or is it an array?
So in using, I may have said this in the past episode, but when I was writing a bunch of C#, I don't know, maybe 2 or 3 weeks ago, as part of sort of like playing with Unity and stuff, and I came to appreciate how much I really like Dart's null safety, because Dart's null safety is sound, and it's just like it is like built all the way in, whereas C# it was, and maybe I just don't know C# well enough, but it was very awkward to know when something was nullable versus not. Whereas in Dart, that's very explicit.
Oh, I'm really doing something wrong here. But we can come back to this.
What are we doing?
I realized that I only want to check 4 things, like up, down, left, right.
Yep.
And so somehow I'm failing to. I tried to write this like inner lambda thing to capture this, but it seems bad. Enclosing scope.
The other thing is you can also just pass the current to it, right? Check like why do you need to update the current? You only need to know. You don't really need to know least nearby. You need to know is neighbor greater.
Okay. Sure.
Right.
Change it.
Is
Well, we should read. Can we read the rules and see what we're supposed to do if there are 2 equal that are next to each other?
right.
The locations that are lower than any of its adjacent locations. So that to me says that it has to be strictly lower, like strictly less than. Like, are there any examples in this example puzzle?
Nope. I think this is just underspecified. It's almost as though the author didn't consider this case.
The locations that are lower than any of the adjacent locations.
I mean, it just seems totally valid, and it seems like both should be low points. So I think that it's more than is neighbor less than. Right? And if a neighbor is less than, then you are not a low point. If there is a neighbor that's equal to you, you can be a low point. So you don't. I wouldn't do this. Oh, okay, this is fine. I was just because you can return as soon as. So I would just have made it explicit. I just make this check. So it's like def is less than x, y value, right? And so then it's like foo is equal to lookup. Oh, yeah, we want lookup x, y. Really, we're just return lookup is less than value. Right?
Okay. So then you want to say if is less than dx y plus dy value. You take a value in here, right?
And value
otherwise.
Right.
Yeah. And then here we'll say if his neighbor is less than x, y value not.
And then we just add ourselves to the low point list, and otherwise we aren't a low point.
Well, the only thing we do with the low point list is compute the risk level. But
sure, we could just compute the risk level right there. Yep.
So I'm not sure that we're reading the question the same way, and maybe when we get the test vectors, we'll see. But I would read this description as the locations that are lower, meaning I would read it as strictly lower than any of its adjacent locations.
That is what it says. It's just what is the height map? Smoke flows to the lowest point.
Which doesn't match the description, right? The description would be like, if you had two zeros next to each other, the smoke would flow there and stick, right?
Correct. It just feels weird that you would just ignore things that happen to be two zeros next to each other.
Mm-hmm.
Like, that's a valid low point.
Yeah,
but I agree I agree that a strict reading of this should not.
This is a reason why you give interview questions more than once. It's because like you need to debug them, because like you want them to be like clear and unambiguous.
Well, that said, my philosophy in interviewing, which may be slightly different yours, is like I kind of don't. I mean, like I kind of want you to get the answer in a direction of correct, but like it's actually more important that you notice things like this in my question, right? Or not that you catch me that I gave you a bad question, but that we talk about you'd be able to explore the question with me. I don't give a lot of technical interviews these days, so maybe I give a lot of managing interviews. Shall we run this and see what it produces?
Yeah.
Oh, you're doing int and stir.
Oh, these are strings. Why don't we turn? How do we turn them into ints?
Yeah.
And
this one. Do we have to return in Python, or does it take the last thing as return? Do you remember?
I believe you have to return in Python.
So that needed an explicit return. Okay, let's try running it. 106.
We're supposed to get 15. So
okay, let's do some debugging.
Why don't we print out all the low points that we identify?
Mm-hmm.
Like I kind of wonder if we just inverted it.
Probably. Wait. 0, 0 is not a low point. So if not, okay, 4. All right, let's just try the first one. Like this should not.
Oh, you know what? This is right. If this is lower, we want to return false.
Is neighbor less than? Why? The neighbor is less than.
Yeah, the name of the function is incorrect.
Oh, what's the name of the function?
So we're looking up here, and we're saying, is that less than value?
Sure.
Right. So this is the thing that's on the lower side. So is, I see, is labor less than value? No, you're right. That was right.
My names are important.
Okay. Is this less than the value? Yep. Is maybe has.
Yeah, has neighbor less than, sure.
Right, so we went and found a neighbor, x, y, and if this is less than that, then we found a less than neighbor. Okay. So if it doesn't have a neighbor less than me, then it's a low point.
Let's print. It's like x plus dx, y plus dy. This is going to be like is less than.
Right.
I think that's how print works in Python 3. I don't. I want to clear this. How do I clear this? Is that clear? Yeah.
Mm-hmm.
Okay. 0, 1. 0, 0.
So why did 0, 0 get printed here? Oh, I see.
I don't see.
Okay, so 0, 0, we should find it's a 2, so it should have a 1 next to it. That's small. And so it should, this number should be small. Right, so why doesn't 0, 0 go down this code path?
And how did it get to?
All right, so let's just print x. X. We'll print x, dx, y, and dy. Okay. And let's, instead of doing this whole range, let's just query this one function for 0, right?
Yep.
Value. Okay. So let's see. Value is lookup 0, 0.
Yep.
Okay, is less than 0, 0 value. Okay.
Yeah, I mean, we used this, not lookup, so that could be part of our contributor, but this will help tell us. Hold on, console.
Okay. Well, let's use lookup here.
0, it says. What does that mean? Oh, print. I mean, lookup has slightly different behavior.
Right. What we do want to use lookup. Okay.
Foo is false. It does not have a neighbor that is less than value. That is not
It's
true.
not what we want. So what is value?
Value? Replit is so nice.
The value is 2, which is correct. Okay.
Okay.
But this never triggered, right?
Correct.
So why this should have triggered for dx. Oh,
is this indented wrong?
No. It's this. We're only looking at the diagonals. We're supposed to be looking at.
We should just enumerate them, honestly. Like,
Yeah. Let's just enumerate them.
like this is sort of.
Right. So it's x.
Yeah.
Y plus 1.
Yep. We can just or here. Like, we don't need to. Yeah.
Or x plus 1. 0. And then the minus ones. X.
Yeah. We only have 4 things. Just enumerate them and be done with them.
Okay.
All right.
I'm confident. Let's go back to our loop. That seems like our bug.
Oh, well, it does seem like our bug. Okay, we were here. We could just test it, but that's fine. Okay. Invalid syntax.
Is this not how you do these things?
Maybe it doesn't like the return or the placement of the return because white space matters. Like, I wonder if this is the way. Yes, that is the way. No, it's not the way.
There must be a formatter. Like, where's the?
Yeah, where is the formatter?
Replit, format my code. Format document. Bam. Nailed it.
Ugh.
Really? That's really the correct formatting?
Cannot
Okay.
right.
I don't believe you.
This time with feeling. I don't know. I did the format document. Like it's PEP8 or whatever, right?
I think maybe you can put like a parenthesis here.
No more trailing commas. That's Dart's solution. Not here, obviously. I'm just.
Oh man. There must be a prettier way of doing this. All right, I can't take it. We're gonna.
You're doing it.
Returns. Yeah, it's too ugly. I can't.
The difficulty here is the return part. That's what makes it splat out into 2 lines. But I agree that it was too ugly. Really, some language must have a like return if true sort of shorthand.
Oh, they have that in Python.
What?
What you mean this? Is that what you want?
Oh,
Uh,
sure. That's slightly prettier.
It's got a quick squiggly line here. Oh, invalid syntax. Maybe that's not legit. I think Python has something like that.
I thought it did. Yeah. On one line if. Oh, is it ternaries now in Python 3? It used to be you could do like a trailing if in Python. Can you not do that?
I think you can.
Trailing if Python, but we're kind of off.
Part of it is the code has to be beautiful. It's an important step.
Python does not have a trailing if statement.
Oh man. All right. Guess not.
Oh, I see. They just have if else ternaries, like where you write out the if and the else for the ternary.
Yeah, it's funny. It's backwards. It's like something, if this, else. They do it in a funny order. Okay,
Huh.
so I think we've mastered this input.
It is, but again, the fact that you have to like use macros to do this kind of stuff. Like in C, you would turn this into a one-line expression with a macro. But again, this is somewhat common. It has come up the idea of I want to check one little thing, and if so, I want to turn this.
Mhm.
But oh, we mastered this one. Great. All right, so let me remove this for 2 seconds so that I can press the login button. Okay, good. I pressed the login button. I didn't even have to do anything. Okay, so now I got my puzzle input.
Whoa, cool.
You ready for this?
Yeah. That puzzle input was much larger than the sample input.
Final input. We're gonna check our answer before we submit to our homework assignment. This one, I think we didn't write any of our test cases.
I'm gonna get rid of your initial line too. Good.
Am I what?
You had a new line here that I took out to match the format.
Okay.
Okay.
1574. Shall we press the button and see what it does? I've
Yeah.
never done Avena code, so I have no idea. Like, does my computer blow up if I get it wrong? Like, 1574. 1574. Submit. That's not the right answer. Your answer is too high.
So let's try the other sense of like strictly lower instead of not strictly lower.
Oh, okay. Where did we do that?
It's sort of like implicit in the way we wrote our algorithm. Like it's like
You want like it's like has neighbor less than or equal to?
right. It's like is greater. This is like all neighbor is greater.
Well, what happens? Why wasn't it just less than or equal to in the previous thing?
To factor these out so that we can change back and forth quickly.
No,
Say it again.
why wasn't it just less than or equal to in the previous one?
You think that's what it is?
Yeah. Also, you changed it to greater here. Is that what you meant to do?
It also reverses the sense of all these, right? Because it's the and instead of the or.
Okay. So greater than all neighbors or something? But
Yeah. this becomes the not gets taken out of there.
So if greater than all neighbors, but that's not what you want.
Oh, if all neighbors are greater. All neighbors are greater.
Oh, so this is the if neighbor is less than or equal to. This is not is greater than. You want is less than or equal to.
I want is less than or equal to.
Right? This is
Yes, you're right.
okay.
Okay.
Let's try it with our test input just to make sure this.
Okay. I expect the answer to be the same.
What do we do?
Install more poetry. 15.
What is poetry? Python goes through like 3 package managers since I left.
Yeah. Binary search it. Well, I imagine we get penalized every time we submit an answer. So can we make a synthetic input that has this issue so that we can see like submarine map
That we changed
with point? Like this 2 is this 1 is a low point, right?
Yes,
This 0 is a low point. Let's turn this 1 into a 0.
And so we would expect the official algorithm or our read of the algorithm to just ignore those zeros, both of them. And so that should mean that the official thing that thinks that it's a 14 is the risk, but we are actually think it's a 16. Is that correct?
Right.
So our original, let's see, our first take should say 16. Our read of strict should be 14. Okay, let's write that down. And that's what we got?
Yeah, so should we try the other algorithm? Has neighbor less than. So I'm going to leave this here commented out.
Let's throw that one. Yeah.
Not less than. Okay.
Okay. So we're expecting 16. Okay.
Okay. So let's try. Let's go back to the new one, and then run the. Okay.
So what did you do? I'm sorry.
I selected final input as our input.
Okay.
So it is less than. So that's good. That's what the website told us.
That's quite a big difference. Let's make sure we didn't break our thing. Can we go back to our? This is going to drive me batty. So this needs to be, what is it? Def strict input. Full. Right.
Okay.
So this needs to parse it. Parse logic. This thing, right?
Yep.
Oh, I see. This needs to be okay. So we can just configure them as arguments here. It's a little puzzle equal to.
But this is also a very common thing that happens in Python, which is you write your thing as one script, and you're like, okay, now I need a real program, and then it's like if you're refactoring into it's actually software. It's like I kind of wonder if you just want to make a class that is like puzzle input, that then you can take all these global functions and make them methods.
Sure, I can't.
It's fine. No, it's good.
My brain can't keep. It's so error prone.
Yeah,
right?
It's so error prone. I completely agree with you, 100%.
Well, so I'm
So we're just gonna
asking for help on how to fix it here.
Yeah. Okay. So let's go back to line 117. I'm just going to say class submarine map.
Okay.
Object, because Python is cool.
Interesting. Why are we graduating all the way to a class?
Oh, I think we make things simpler.
Okay.
Instance, and we want to say first equals. We just take all these basic global variables and make them class variables.
Okay, that's fine.
Okay. Let me say.
Okay.
These constants really are constants, so we can just save them up here.
Okay.
And then look up, just promote to a class function, point.
Well, doesn't need to be self at the beginning, yeah.
Okay. Okay. Well, the other thing I like about Python is like this refactoring is easy. Like all I'm doing is like reindenting.
Yeah.
And adding the self parameter.
And Python has first classes, so we can just pass the method around. Like we can pick our algorithm method. Because really the only thing we need to change is this. It's like
we can also create subclasses.
It's like lowest check is either equal to or has no whatever. You're refactoring.
What do we want to call it? Like X. So you're way better at naming things, so I'll let you name it correctly.
This is risk level allowing yeah, just risk level and risk level strict, basically.
So loose.
Sure.
There's a risk level with common low points, right?
Sure.
So ignoring.
Okay.
There's some way of sharing code between these things, but
yeah, I mean, yeah. There's lots of ways.
This is right, the other one, right? All neighbors are greater.
Yeah, and then you just pass in the function. Risk level and then check.
So this is going to be like, what are our two examples? Submarine map. Oops.
Yeah, the idea was I wanted to print out all 4 cases that we were checking.
Yeah, we're totally going to do that. I don't know what we call this. Object. Please tell me.
Isn't it just a one-liner, right? Oh, I see.
Okay. Sure. Risk level with common low points.
Submarine map. Whatever's the first one. This is I'm calling this oh, I see.
I'm going to say like print.
We have 6 points, right? Right. You want right. Test input. This is test. No. right? And then this is going to be like.
You just create the map once.
Oh, I see. Okay. Fine. Sure. Mm-hmm.
And then we can say, oh, I lost something.
Okay.
You're trying to make a function that's like solve input, right?
That's fine. You're getting there. I should just let you keep. Input is a free function in Python, yeah.
Everything is a free function in Python.
They have a few keywords, but at least they. I think I told you about this in the past episode about the C# that I was using does not understand that event is in fact a keyword. So when you type event, C# gets really mad.
Okay, what do you want to call this? Maybe like a name. Like, what is the name of the puzzle? Name. Goose. Goose.
Oh, I see. Okay, that's what you're doing. Okay.
All puzzle input, like original.
Mm-hmm.
Tap.
Mm-hmm. Original with common or whatever, yeah. Yep. I now see what you're doing.
What was this? With common?
Yep.
I thought I wasn't communicating verbally very well.
That's fine. Sometimes you just have to like. It's important to just like let people get their thoughts out, so then you can talk about them. Just how it's important for people to write their thoughts down.
Okay, try that.
Okay. Okay. Original. This is wrong.
Something is one horribly wrong.
Because these are probably pulling from. Self lookup? What is going on?
What is going on? Okay, let's just get rid of these two.
There's some like. What is going on?
I have no idea. Can you run it? Let's run this. I don't understand. Okay, now we're going to comment out these things.
Solve?
Something very bizarre has just happened to us. Okay. Final input is not defined. Aha. Here's the bug. The bug is on line 123.
Yes, that would be the bug. It needs a puzzle. Are we not?
There we go. There we go. Double variables. Not even once.
What did you do? You didn't change anything. This needs to be instance, right?
Oh, the tubes are clogged. What happened?
Oh no.
It looks different on my screen.
Well, the internet is not a series of tubes.
Can I type up here? No, I've totally.
Okay, I'm gonna refresh. Refresh.
All right, I'll refresh too. Oh, changes. It told me that changes I made may not have been saved.
Oh no, I don't want you to have. You don't.
Which I agree. Oh, it looks like what I had. What does yours look like?
And you can't just back a dump truck. They have puzzle.
Okay, let's try running this.
Original. Okay, much better.
Legit. Okay, now we'll uncomment these.
Okay. Okay.
Should we type it in the webpage and see?
Let's try 444.
What did we win?
I suspect it'll just tell us we can continue on our merry way. That's the right answer.
Whoa!
Oh, we got a gold star.
How did we get a gold star even though we got it wrong the first time? Did we get like 2 gold stars? Did we get it right the first
I
time?
think it's like an advent calendar.
Wait, continue to part 2.
What? There's a part
What?
2? We're out of episode time.
What? I was not informed there was a part 2.
If I did,
We would have gone faster.
we would have budgeted our time differently. I think the interviewer here failed to manage our expectations.
All right.
It's like getting to the end of the interview, be like, okay, thank you for answering my intro question. I have 7 more. Okay, this is great. I just wish I'd known.
Maybe this is common for Advent of Code, and if we were not complete Advent of Code noobs, we would have known to expect a part 2.
I'm sorry to all of you watching this who are like, who are these idiots?
Really, well, why are they polishing their code to be beautiful and like object oriented? Didn't they know they had to get to part 2? We have no idea what we're doing. This was fun.
I had fun. Maybe we should do some more Advent of Code. And now we know that we can just cheat through our way. Look through the power of the web. Let's see what happens if I do part 3.
You totally have not unlocked part 3. You have to get your gold star.
Are you saying that this website is safe against my attacks?
You have to attack it by writing code. The only way to hacksaw it is to solve the problem.
Oh. Okay. Well, I guess that was our episode. We did part 1 of number 9 of this year's Advent.
Tune in next week.
Yeah, tune in next week.
We'll have it next week. We're just going to whip out part 2 as fast as we can, and there won't be a part 3, and then we'll just be like,
oh. Any news from the land of pizzas?
Yeah, we've lost all topping discipline in pizza. So we just
What does that even mean?
all right, so we make more than one pizza for pizza night, right?
Okay.
But like you don't know how many. So we like red onions on the pizza, so you cut up a little red onion. But of course,
as does everyone, please,
as you do. And so we put enough red onions on the red onion pizza that it gets its appropriate amount. But then you have some left over.
Mm-hmm.
So by the time you get to the last pizza of the night, you just have a little bit of leftover toppings from all the other pizzas. And I'm not going to throw this away. So that pizza just becomes the mishmash of everything pizza, which of course is the best. But then you have no idea what you put in it, and there's no way of ever replicating it.
So last week I did the pizza. I followed the Bible, as the pizza Bible or whatever, and I did the whole masterclass thing. This week I'm making pizza again. I just don't really want to spend 3 days making dough.
So I'm going to respect the craft.
What'd you say? I do need
to respect the craft.
I should respect the craft, just like I didn't respect the puzzle tonight. But I instead am going to disrespect the craft and do a quick dough and demonstrate that it can't be like whatever the slap method. Like I'm sure that'll all fall apart. But I'm going to learn how bad a quick dough is relative to the.
What is the difference between the regular dough and a quick dough? Like what makes a dough a quick dough?
Oh, you just you slap it together. We have some pizza dough recipe that, we've used with our friend group for 15 years or something like that. And it, because we used to start it at 5 o'clock on a Friday when we all got back from work, or 6 o'clock on a Friday. And, it takes an hour or something. It's just like a bucket full of yeast and some flour. And then an hour later, you have something resembling dough.
Did you watch Stephen Colbert?
I watched a good bit of Colbert. He is so good at his job. Just
he has a segment called Meanwhile.
Yes.
And the Meanwhile segment, when he introduces it, it's fine. Just telling us for the sake of the audience. He first explains this very exquisitely crafted thing. And then he says, but sometimes, and then he's talks about how he just totally takes together a bunch of garbage and makes the thing, right? This is like the first version was last weekend.
Yes.
But sometimes you just throw together a bucket of dough and flour that you found in the backseat of your car.
I really enjoy watching people be incredibly good at things. So I'm actually watching. I'm teaching my kid about speed running, not so that they speed run, but just it's for the same reason I enjoy watching professional whatevers. And part of what I enjoy when I watch Colbert is it doesn't matter what he talks about so much as just watching him at the craft of comedy.
Or even just the craft of communication. Just like he's a really
Yes.
clear communicator.
Oh, it's just I love watching people be really good at things, and he is really good at his job. Like him or hate him, he's really good at his job. So, anyways, that was our time. It was amazing working on 2021 Advent 9 Part 1 of Knows How Many with you tonight, Dr. Barr.
It was a joy for me as well.
Well,
thank you for tuning in, and we will see you next week.
Yeah. Have a good one, all. Take care.